So, continuation of the two-port network topic. We are solving problems in two-port networks. Almost we came to the end of the topic. So, let us go through these problems. So, in this, find ABCD parameters. This is all asked in gate 15. Simple problem, T network, but these impedances given in complex form. Find ABCD. So when he is asking ABCD, better use shortcut method. Don't open, don't short input or output port. Just write mesh equations and convert or express V1 I1 in terms of V2 I2. As simple as that. So if this is I1, this is I2. Current here is I1 plus I2. So V1 is equal to, just return this equation. Just write this equation. V1 is equal to 5 plus J4 into I1 plus I1 plus I2 into 2. So simplify, you will get this. Then this is equal to, again now write this equation also. You will get this. So here V2 is 5 minus J4 into I2 plus 2 into I1 plus I2. And here further simplify, solve for I1. Solve for I1. So this I1 substitute here. I1 substitute here. So here V2 by 2 minus 7 minus J4 by 2 into I2. So this I1 in place of I1, written this one plus 2 into I2. So further simplify, and we want V1 in terms of V2 I2, and we want V1 in terms of V2 I2. V1 in terms of V2 I2, then I1 in terms of V2 I2. So I1 in terms of, so this is the first equation. This one is second one, second ABCD. Now compare the coefficients, you will get to ABC. It's so easy. Just write the equations, express in ABCD parameters format. Compare the coefficients, you will get to ABCD fastly. And don't open, don't short. If you go by step, that will take more time. So this is the best way. Now this is another problem. ABCD given, in this box ABCD given, externally 1 ohm resistor is connected. 1 ohm resistor is connected. Find ABCD of complete network. So what is the best way of solving this? When we want complete network, when two networks are connected in cascade, ABCD parameters are multiplied. ABCD parameters are multiplied. That is easy way of doing. What is the other way is V1, here V1 I1, V2 I2 for this box, and here V1 prime, I1 prime I use. So for this network 192 is ABCD of this box, and V1 is equal to V1 prime, then I1 prime minus I1 is equal to V1 by 2. So this fourth equation. What is the current over here is V1 by 1. So V1 by 1 is the current. This current is nothing but I1 prime minus I1. Then V1 prime is equal to V1 prime is equal to 2V2 minus 3I2. So here V1 is becoming V1 prime. So these 5 equations manipulate and simplify, then you will get ABCD. This is one way of doing. What is the other way is draw this 1 ohm separately. This is separately. So this is V2, I2, 1 ohm, V1, I1. So this network find ABCD. How to find ABCD? V1 is equal to, what is the current here? I1 plus I2 na? So I1 plus I2 into 1. So simply I1 plus I2. Second equation V2 equal to again I1 plus I2. But we want V1 in terms of V2 I2. So here what is I1? I1 is V2 minus I2. Now in this equation V1 is equal to, what is I1? V2 minus I2 plus I2. So therefore this is V2 only. So V1 equal to V2. So V1 in terms of V2 I2. The next I1 in terms of V2 I2. So simply this equation straight away we want I1 in terms of V2 minus I2. So V1 I1 in terms of V2 I2 we have written. And what is the A value from this? A is equal to 1, B is equal to 0, C is equal to 1, D is equal to 1. Here C na, C equal to 1, D is equal to 1. So A, B, C, D, that means 1, 0, 1, 1. This matrix is multiplied with this 2, 3, 1, 2. 2, 3, 1, 2. So if you multiply, you will get same answer 2, 3, 3, 5. You can verify, you will get same answer. So it looks easy. This is also not lengthy. Any one of the way you can, but this method is best to comparing with this. So both the methods I have done. So this is another interesting model. Find Z22. Here is transformer is there. Transformer. So in this transformer, resistor R is connected here. So there is a resistor R here, and this one is a transformer 1:n. So V1 I1, V2 I2 given. Find Z22. What is Z22? V2 by I2 when I1 equal to 0. So I have drawn circuit again, making I1 0. I1 0 means this is open. This is open. This is open. So what is the voltage here is V1. Voltage here is V1. That is already there. Now the what is the current here? I2. Now what is going through the transformer is I2 prime. I am assuming I2 prime. Then current in this will be obviously I2 minus I2 prime. So I2 minus I2 prime is entering here. The same current is entering here. So what is entering here we know. What is entering here we know. So accordingly write the equation. So V2 by V1 is equal to V2 by, what is the voltage here? V2. So V2 by V1 is equal to primary current. What is the primary current? I2 minus I2 prime by minus I2 prime. Because as I told earlier, any transformer, what is the rule? Any transformer, what is the rule is? Here this current should leave. I2 should leave. So there is a dot. This current should enter. This is V1. This is V2. So under this condition only, V2 by V1 is equal to I1 by I2. So same way, V2 by V1 equal to what is the current entering? I2 minus I2 prime by minus I2 prime is equal to N as per the transformer formula. That is one equation. The second equation is V2 is equal to, so to write this equation, V2 started positive, go through the resistor, then come to negative. So what you get, R into V2 is equal to R into I2 minus I2 prime plus V1. This is second equation. Now R into I2 minus I2 prime plus what is V1? V2 by N. V2 by V1 equal to N. So this is replaced with this. Then another formula, I2 prime minus I2 by I2 prime is equal to N. Okay, I2 prime, here I2 minus I2 prime by whatever way, both are same only. So just equations important. Here from this I2 prime is equal to I2 by 1 minus N. From this equation simplify, you get this. So here I2 prime is replaced with I2 by 1 minus N. So like that simplify, take the ratio V2 by I2, you get this. So I'm not focusing much on mathematical simplification, just to go through, you will get it. How I have written equations only important. One is the voltage ratio, second one current ratio, third equation V2 equal to, understand, if you just understand equations, then solve them, you will get the answer. So this is another problem. Here also transformer is there. Here also transformer. Very simple. Transformer. So here 8 ohm resistor is connected. Here there is one 8 ohm resistor. Turns ratio 1:2. Okay. Here 5 unknowns problem. So find V naught. Your question is to solve for V naught. So V naught is across 8 ohm. This V naught is across 8 ohm. So how to solve this? So here voltage V1, here I1, I have written nodal equation here. Here one nodal equation. So 60 of 0 minus V1 by 4 plus V naught by 8 plus V naught by 8. So this current is entering equal to I1. Here this is equal. This is entering now. This is equal to V naught by 8 plus 1 plus I1 is equal. So sum of the currents entering equal to sum of the currents leaving. What is this is I1. This current is V naught by 8. So 60 of 0 minus V1 voltage here. V1 by 4. This is entering, these two are leaving. That is one equation. The second equation is here, nodal equation here. So these two are entering, other one leaving. What is entering? V0 by 8, then I2 entering is equal to minus V0 plus V1 by 8. So what is the voltage here? To know this voltage, start here, go to ground. Minus V0 plus V1. Minus V0 plus V1 is the voltage at this node. Okay. So minus V0 plus V1 by 8. These two are entering, this is leaving. This is second equation. Third equation, I2 is equal to, this I2 is equal to V2 minus of minus V0 plus V1 by 2. What is the voltage here? V2. What is the voltage here? Minus V0 plus V1. Difference by 2. This is third equation. Then transformer V2 by V1 equal to 2. Fourth equation. Then I1 by I2 equal to 2. Fifth equation. So just voltage equation, current equation. Then this will form one node, this will form another node, and two nodal equations. Okay. Then and 5 unknown, 5 equations. V0 is there, then I1 is there, I2 is there, V1, V2. So 5 unknowns to solve for V0. This is a not asked in gate. It's a conventional problem, little bigger one. But idea of how to write equations. This is another small problem. The H parameters of two-port network is given. The new H parameters results if 1 ohm resistor connected in series with the input is. So this 1 ohm resistor is connected here. 1 ohm is connected. This is the H parameter. I told you now earlier how to draw the equivalent circuit of H parameter. So this is H11. So V1 in terms of I1, V2, then I2 in terms of V2, I1. That's H parameter standard. So 9 minus 220.2 given. Na? So this is the equivalent circuit of H parameter attached with 1 ohm. Find H parameter of complete network. H parameters are added if it is series parallel. G parameters added if it is parallel series. So that cannot be used here. That's why this is a special problem. Now consider this as a whole network as a one problem. Then we want H parameter of whole na. So don't short, don't open. Use shortcut method. Write equations and solve. Write equations and solve. So just written here V1 here for this V1 I1 V2 I2. So V1 I1 already used here na, here V1 prime I1 prime. Or if you use this is V1 prime I1 prime, then this is V1 I1. So either way you can do it. So V1 prime is equal to I1 prime into 1 plus 9 into I1 prime, because I1 prime is same, then minus 2 V2. So simplify this one, we'll get this equation. Then I2 is equal to 20 I1 is the current, 0.2 V2 another one. Now V1 prime in terms of I1 prime V2 one equation, I2 in terms of I1 prime V2 another equation, then express in matrix form. This is the H parameter of complete net. So these are all small problems. Here find Y parameters. This 2 ohms connected parallel with 111. 111 is a T network. 2 connected above. So it comes under parallel. Parallel, what is the idea? Y parameters are added. Now 2's draw separately, find Y parameters. 111 draw separately, find Y parameters. Then add them, you will get the answer. Instead of that, this is a little bit easy. So 111 I have taken, and this two is connected here now. So I have connected here again. So same circuit redraw, taken as a one problem, completely as one unit, one problem. Then using shortcut method, I have written the equations. and compared with the standard form, I got the y parameters. So all possible equations. Here one nodal equation, here one nodal equation, here one nodal equation. Here one unknown VA is coming. So nodal you know how to write. So write equations and I1, I2 express in terms of V1, V2. I2 express in terms of V1, V2. Compare, you will get the y parameters. So like this you can solve or find individually, add y parameters. That is also no problem. This is another bit. Consider a two-port network with the transmission matrix T. If the network is reciprocal, then reciprocal means condition for bilateral. What is the condition for bilateral? Determinant of T matrix is 1. That means AD minus B is equal to 1. So determinant of T equal to 1 is the answer. Is asked in gate. So find Z21 is one bridge T network. T and there is a flyover bridge T is asking only Z21. It's asked in gate 17. This is the small problem. So easily you can do it. Answer given. He asked only one. If it is asked only one, V2 by I1, I2 equal to 0. So open, use current distribution, write equation and manage. Now find ABCD. This is also straightforward. Network N1 ABCD given, network N2 ABCD given. Find ABCD of combined network. So just to do the matrix multiplication, answer is A. So in this, find B. ABCD network, he asked only B. So minus B equal to V1 by I2, V2 equal to 0. V2 0 means short circuit. So this current I2, this current I1, here I1 plus I2, write mesh equations and solve. You get 4.8. Ask in IES. So there is a Y network. For the two-port network shown, the Y matrix is given, Y parameter matrix is given. Obtain the input admittance Yin as shown in figure. Obtain the voltage gain V2 by Vs. V2 by Vs is one question, Yin. Yin means I1 by Vs. So since Y parameter given, you write equation 1 and 2. I1, I2 in terms of V1, V2 na. So Y already given. Then V2 equal to minus I2 into 1. So minus I2, third equation. Now what is Yin? I1 by V1. I1 by V1. Okay. So V1, so just to go through these steps and we want to eliminate all unwanted I1 by V1. So you got the answer. See, these things, just to write equations yourself, compare with the answers. Okay, if there is any doubt, you compare with my steps and learn accordingly. Okay, so just writing 1, 2, 3 is important. Then eliminating unwanted and whatever we want to do it. So just mathematical simplification. Go through it, you will get the answer. Here, as the given network satisfying reciprocity condition, Z1 to equal to Z21, the I1, the I answer is asking. Using reciprocity theorem, when 5 volts given, 1 ampere here. This side is 5. What is the current? 1 only, na? As simple as that. Using such as small questions also, sometimes they ask. So this is op amp based. Find it is also IS. Find Z parameter of complete network Is the network reciprocal? If so, why? Op amp is ideal. So with op amp is asked. So op amp, what is the basic character? Input impedance is infinite. Current will not flow into the op amp. So therefore this port V1 I1, this port V2 I2, in between op amp and other resistors are connected. So V1 is equal to I1 into R1 plus R2. Why R1 plus R2? What is the current in this? Zero, na? If this current is zero, I1 will, what is the current here also? I1. So that's why V1 is equal to I1 into R1 plus R2, one equation. Then this V2 is equal to I2 into R3. I2 into R3 plus what is the voltage here is Vx. Vx we are assuming. If this is Vx, here is Vx. Here is Vx. So due to virtual short, what is the voltage here also? Vx. So when I am writing equation for V2, V2 is equal to I2 into R3 plus what is the voltage here? Vx into R4 by R5. Vx into R4 by R5. R4 by R5 is voltage across R4. Voltage across R5 is how much? Vx. So Vx. Now I2 R3, Vx common, then is equal to I2 R3. Then what is the value of Vx? I1 into R2, na? I1 into R2. So to find the Z parameters, what we have to do? V2 expressed in terms of I1, I2. I expressed in terms, so this must be Z11. This must be Z12. Next, V2 equal to V2 is equal to R2 into V2 is equal to R2 1 plus R4 R5 into I1 prime, not I1 prime, I1. Same thing, I2 R3. So this I1, not I1 prime. I1 into R2 1 plus R4 by R5. Same V2 expression. So V1, so V2 in terms of I1, I2, already got it. V1 in terms of I1. So this is one equation. This is another equation. So Z11, Z12, Z21, Z2. Just compare, you'll get the answer. And here Z12, Z21 not equal, therefore non-reciprocal. Therefore non-reciprocal. So with this, almost all the problems over. So all of you subscribe my YouTube channel, namely CH Ganapathi Reddy, the bracket CGR. All of you please subscribe to my YouTube channel. That will be helpful to you. So thank you. This topic almost done. So I am closing this session.